Hello humans, welcome back to the Touchdesigner training course. Today is the Surface family turn. Today we are gonna see the Sweet 16 subs. Again, to begin we need our Touchdesigner project open. Again, we are going to the help, operator snippets, and today we're going to begin with the circle. The purpose for the circle is to make circles, spheres, or torus primitive. So let's see first. We go to the subfamily and we're going to select circle. In this first example, we are going to explore how is that the radius works. We find here a circle with a regular 1 by 1. This is the default circle that we get. You can see it's coming always with a radius of 1 and x and y. And you can see that here we can find the same element but just with a different radius. So here we have two axes, one for the x and one for the y. We can also change divisions. If we go to the circle, we will find here by default one circle with 40 divisions. If we can see that, we can go activate our surface step on top of the operator and press the key P. Every time that we press the key P, it's going to appear the selection viewport and we can check the points. We can even give them a number. And here we can see that this one just has 3 divisions and this one has 4 divisions. See, beginning from 0. So it's 0, 1, 2, 3, 4, 5 in this case, but at the end it are 6 divisions beginning from 0. We can also work with with open arcs or closed arcs. That means that one of them it uses the fill element and the other one is just the wire. And you have more examples. The next one is grid. Here the grid we can see the difference between the rectangle and the grid. Again, we are going to activate the point. And here you can tell what is the difference between them. We can also activate the wireframe. If we stay on top of the operator, we click W key and look. When we are talking about the rectangle, we just have 4 corners, but here when we are talking about grids, we find a point in every cross of the columns and rows. So here we have more vectors and more information. The next one is merge and delete. Here we can see how just using one merge in the same way that we will use it in shops or in DATs. In this case, we are making one operator with multiple inputs of different surfaces. So you can see how all of them are here aggrouped now. The next one is copy or replicate. So look, you can make a copy preserving the same aspect of the input, of the first input, or you can make a copy where there is also one parameter that can be changing with every copy. For example, here this second is changing the scale with every copy. So here we have the complete box, after that we have half, after that we have the half of the half, in that way is going to keep copying. And we also have a parameter where it's changing the rotation but not the scale, so you can see how it's rotating with every copy here. We can also use two inputs, one to define where is the position of the first. In this case, you can see how it's replicating the torus with every vector in this grid. But you can see also how the open arcs works. The next one is switch. Switch or blends multi-inputs. And this is exactly also one of those operators that we can also find in chops, in tops, in dats, in materials even. And look, at the end, it's just a list. It's an operator with a multi-input, and inside there is a list where we can change our input. So we have different elements, boxes, spheres, torus, for example. We use a switch. And here we just need to select from 0 to the last. There are options. Our next operator is texture. Apply texture coordinates to points or vertices. In this case, when we are talking about surfaces, we also know that the information of the vectors are not the only information that we can use to make 3D content. There are a few other kind of elements, and in this case what is making this operator is to assign a specific parameter to every vector. In this case, this parameter is used to define the way that the texture is going to work on top of our operator, of our surface operator in this case. So you can see here we have an input box with 4 different options in this column here, and you can see how the tiles or the material it's been applied on top of the surface. In the first example, there is a repetition, and you can see how the corners hold everything to the next corner. This one is the same but without the repetition. Here we can see also the same process but with a sphere. So look here how this sphere is remapping everything on top, but it still has this knot here in the very top bit. And you can see here also an sphere, but these sections are organized in a different way. Look, you can see here the cross. So everything depends also how is your surface made, that the information is going to be wrapped on top of the surface. Our next operator is noise. Applies noise, twist, and deform. Here in the same way that we were working with the noise that we can find here in the tops or here in the chops. When we're talking about noise, is because we're using a random value. In here, what it's moving, that random value is the position of our vertex. So for example, you can see here also P numbers, no, just points, and W, and we can activate also here the same W and point. And at the end, what is happening here is that every point on our sphere is moving randomly, and in that way our surface is going to deformate. We can also use it to move the normals but not the position of our vectors. So you can see how here it looks just moving normals, or we can even use a diffuse color. There are also textures, noises. You can check those examples. Our next operator is the transform, and in the same way that we use it also in our other families, the transform has the parameters to use our operator in a 3D context. So look, we also know that we can find transform in every geometry operator in the Xform family, in the Xform page, sorry, and here we will find the translate, rotate, scale, and pivot. Those are like the basic elements that we need to interact with our element in the 3D context. But also those same parameter we will find it on our operator transform. So here translate, rotate, scale, and pivot. So again, we'll see here our input with different changes in every example here. And at the end, they're using a merge and they put it together. We'll find the same here, just scaling in one axis. For example, they are scaling in the x-axis and giving the half of the extension. And we can also use it to rotate, or we can define it to look at. For example, when we are using camera, we can define where is the place where we need to look the camera always. The next is that table to sub points. In this case, our translation from one kind of information to another, from one nature of to another, is bringing the information from every vector and organize it inside a table. So what happening here is that they are copying this circle that it has just 5 corners, and they are using a copy to multiply it, and after that they are translating all of that information to a table, and they after that also use a that2 to reinterpret the information, and we can see that here we have the same result. So they began with this, they create this composition, they translate it, and also after that they go back to the same nature of information that is surface, and we can see here that we have the same result. Our next operator is the shop2. Here we are going to make a translation, but in this case it's going to be from the shop family. So they are also creating here a noise, make a trail, and that trail they are translating it in a 3D visualization. They are using here a line with 200 points, and here we have 200 frames of information. So what is happening here is that every position here in this graphic, it's being updated here in this line, and that's why our wave here, it has the same aspect of our wave here in the visualization inside the shop operator. The next one is the trace. This one is a really useful operator, the trace, because what it's doing is converting the information from a 2D context, and it's transforming that information to 3D context. In this case, it keeps all the silhouette that create a silhouette with a line that it's filled, and that plane that we get here, it can be extruded, and we have now a 3D object based on the behavior of one texture. We can also do the same with a movie, for example, and you can see here how all of this is becoming 3D information with vectors. Again, we can activate our points. And for example, we can also change here our input, and it's going to keep working also. Our next operator is clip. The clip operator is made to cut 3D elements based on a plane. The plane that we can find here in every clip operator is the reference of the position where our object going to be clipped. So for example, here they are using the clip in the horizontal way, and the way that we change the position is using the direction. So you can see here it's horizontal, here it's vertical, here is moving to the front and the back, and here is diagonal. And also depends how is your element, this is going to keep or not some information. You can decide if your content it keeps the information below or the information on top. For example, here it's keeping the primitive above the plane, everything that is on top of that plane. But if we use the opposite, it's going to keep everything that it's below, and the same with the rest of the elements. Our next operator is particles. This is one of topics that you were asking me, and this is something that we are going to work today with our manager dragon. We go to particles, and here what we're going to find is the way that the particles can be expressed. At the end, what is happening here is that every vector that can be created from our source, it will be the birth point of a particle. So every point here, it can convert to a particle. For example, here we are looking how this is being organized, the birth of every particle. So here we can visualize the points too, and in this case the points are moving. And it's because at the end every particle has the information of a vector, but it's moving in the space. The particles can move as a particles as a individual elements, or also can deform our surface based on the movement of every vector. Also, there are a few elements that we can make, like calculating collisions and making a behavior for every particle after a certain kind of conditions. For example, in this case the particles is keeping stitched on the walls of the surface that it's around it. Here every time that the point touch the wall is going to die, or here for example is just going to stay until the time ends for the specific particle. We can also use physics like wind, and we can change it the intensity. We also can change the direction if we put information in different parameters. For example, this one that's moving in diagonal. We can give it turbulences to make it even randomly. And we have so many other examples that we are going to check. Our next operator is sweep, skin, and rails. Our sweep operator, what is making it a kind of trail copying. In this case, this circle is the base of the trail, and you can see how in every point our first input surface is being replicated. Here is doing the same, but look like a kind of extrusion, but having in base the trail that is the second input. Or look how also is twisting our elements based on that trail. And our last operator is sort and reorder. So here the sort, what it's doing is that it can reorganize the elements. In this case, for example, is reorganizing and changing the position of our points. Here it's turned on. We can see here the 0, the 1, the 2, the 3, 4, 5, and after they put the sort, they are changing the position of the elements. It keeps, in this case, the structure because there are not so many vectors, but the position of the numbers are changing based on the input. For example, here they are doing this change in randomly. You can see how the numbers change here. And it can also be applied to particles, for example, to make that behavior even more detailed. And those are the Sweet 16 for the surface operator family. There are so many ways to interact with this. Again, my invitation is to check in a deeply way our operator snippets. You will find so many examples and contexts where the elements can be applied, and you just need to replace the inputs. Thank you very much and see you in the video call.